Now let's look at the problem 36. And let's look at the cosecant inverse of 2 over root of 3. By the relationship between the cosecant and the sine, let's review this. You have the inverse cosecant x equal to the inverse sine of the 1 over x when x its absolute value is greater than or equal to 1. Right? So right now, this guy is really greater than or equal to 1. So this is equal to inverse sine of the root of 3 over 2. Then what is angle? Pi over what? 3, right? Pi over 3 is the 60 degrees, but it's not the pi over 6, right? Pi over 3. And let's look at the problem 66. And this is on the page 486. We try to evaluate this expression involving the inverse sine. So first, let's evaluate the inside. What is the arc sine of the 1 over root of 2? Pi over 4, right? So this is equal to pi over 4. And then, if you are not familiar with the secant, you can use the cosine. This is equal to 1 over cosine of the pi over 4, right? And the cosine of the pi over 4 is equal to root of 2 over 2. Then you simplify this complex fraction by multiplying both the numerator and denominator by 2. Then you get 2 over root of 2, right? And you can rewrite the 2 as the square of the root of 2. So you have the 2 factors of the root of 2. Right, this guy, this product is equal to 2. So you cancel 1 root of 2. Then finally you get root of 2. Now let's look at the 68. And let's look at the inverse tangent of the sine half pi. And sine half pi equal to what? Sine half pi, this is the simplest. 1, right? So if you cannot remember the sine half pi, then you are finished. Okay, so inverse tangent of 1, then equal to what? Pi over 4, right? This guy is equal to pi over 4. Now let's look at a tricky one. Problem 72. Arc cosine of the negative pi over 3. We know when you compose the arranged function with the inverse function, they just cancel with each other, right? And then you get the identity function. Now, this is the cosine. This is the inverse cosine. Can we just cancel this to get negative pi over 3? maybe in your mind, this is what you want to do, right? But here, it's kind of tricky. So, first, let's get the cosine of the negative pi over 3. What is the reference angle of the negative pi over 3? See, you draw the sketch. Right, this negative pi over 3. Then what is the reference angle for this angle? Pi over 3, right? It's angle formed by this terminal side and the positive x-axis. So this equal to cosine of the pi over 3 up to or sine. Then what is sine of cosine in the quadrant 4? Positive or negative? Positive, right? So it's positive. Then that's why it's just equal to cosine of the pi over 3. And what is the cosine of the pi over 3? 1/2, right? 1/2. Okay. So now we get the 1/2. Then let's go back to this original problem. We have the arc cosine of the 1/2, right? This original equal to this guy. Then what is the arc cosine of 1/2? What is the arc cosine of 1/2? Pi over what? 3. Right? 60 degrees. Whose cosine is equal to 1/2. Now you look at this again. Is this equal to negative pi over 3? No. The problem is this negative pi over 3 is not in the range of the inverse cosine. The range of the inverse cosine is from the 0 to pi. So you just cannot simply cancel this original function and inverse function to get the answer. So this is a little bit tricky.